Hey everyone. So if you're gearing up for a technical primer exam, you know it can feel pretty overwhelming, right? Well, today we're going to cut right through all that noise and focus on the absolute core concepts that you're going to see time and time again. This isn't about memorizing stuff, it's about really understanding the fundamentals that take you from just passing to totally acing it. Let's dive in. All right, so what is the secret? What's the magic trick? Is it about knowing every single obscure bit of syntax, or is it just pulling all-nighters with a ton of coffee? You know, the answer is probably a lot simpler than you think.
See, here's the thing. The key isn't brute force memorization. It's all about building a really solid foundation. These exams, they're not trying to trick you. They're designed to see if you actually get the core principles. Because, well, that's what makes a fantastic developer. So today, that's what we're going to do. Build that foundation, one piece at a time.
Okay, our first big pillar is about the big picture, the architectural principles that make software well-structured and easy to work with. You can think of this as the actual blueprint you'd use before you even think about laying the first brick of code.
So right here, we've got two of the most important goals in software design. First up, you want high cohesion. Think of it like a perfectly organized kitchen drawer. All the forks are in one spot, all the spoons in another. Each part of your code has one clear job. Then you want loose coupling. This just means your different code modules aren't all tangled up in each other. A change in one doesn't cause a domino effect and break everything else. The golden rule you always aim for is high cohesion and loose coupling. That's the recipe for code that's a dream to maintain and reuse.
Another super important concept is information hiding. Now, the idea is simple, but it's really powerful. You basically protect the inner workings of an object from the rest of the world, and you only show what's absolutely necessary. This stops other parts of your code from messing with things they shouldn't be, and that leads to a classic exam question.
Which brings us right here. It's a classic for a reason. In object-oriented programming, or OOP, there are a few big ideas. But which one is the specific tool, the actual mechanism, that lets us do information hiding? Go on, take a second and think about it.
And there it is, encapsulation. That's the one. Encapsulation is all about bundling the data and the methods that use that data into one single neat package, called a class. It is the principle that directly makes information hiding a reality. You have to remember that connection. It's pretty much a guaranteed point on the exam.
Of course, you can't build anything without the right materials, and that brings us to a fundamental choice you'll always have to make. Arrays or linked lists. Arrays are super fast if you know the exact spot, the index, you need to get to, but they're rigid. You can't just change their size. Linked lists, on the other hand, are way more flexible. It's easy to add or remove things. But what's the catch? You have to go through them one by one to find what you're looking for. Knowing when to use which is a huge part of the game.
All right, let's move on to our second pillar. Now that we've got the blueprint, let's head down to the engine room. This is all about the nitty-gritty, the actual logic and flow of your code as it runs, line by line.
And here's another question you will almost certainly see, this time about control structures. You've got your for loops, your while loops, but what if you have a situation where the code inside the loop has to run at least once, no matter what? Which one do you pick?
The answer is the do-while loop, and the reason is actually pretty straightforward. A regular while loop checks the condition before it does anything, but a do-while loop, it does the action first. It runs the code block, and then it checks the condition to see if it should do it again. That's the key difference, and that's why it is guaranteed to run at least one time.
Okay, so you're going to see a lot of questions that show you a little piece of code and ask, what's the output? And it might feel like they're just testing your memory, but they're not. What they're really testing is your grasp of the fundamentals, how code executes, how errors are handled, how array indexes work, and how loops behave. If you get those concepts down, you can solve any of these problems.
So for our third and final pillar, let's zoom back out. Because it's not just about writing lines of code, right? It's about the entire process, how that code gets built, tested, and delivered to people in the real world. This is the modern software development lifecycle.
And a massive part of that modern lifecycle is what we call the agile mindset. You know, unlike the old, rigid ways where you had to plan every single thing from the start, agile is all about being flexible. It actually welcomes changing requirements. You work in these short, focused bursts called sprints or iterations, and you're constantly delivering working software. It's all about collaboration and moving forward in a cycle, not just a straight line from A to B.
So once you've built something, you obviously have to test it, and it's so important to know the different kinds of testing. A question that comes up a lot is about who is doing the testing. When you have real users, the actual client, testing the product out in their own real-world environment, that's beta testing. It's one of the final checks before a big release.
But what about testing things like speed, security, or how many users the system can handle at once? Well, that's system testing. System testing isn't about if a feature works, it's about how well the entire system holds up under pressure. So think of it this way. Beta testing is about function, done by users. System testing is about performance, done by the dev team.
And we can't really talk about the development lifecycle without talking about data. So here are two database concepts you absolutely have to know. First, the primary key. It's basically a unique ID for every single row in a table, like a social security number for your data. Super important. It can never be empty or null. Second, the outer join. Okay, imagine you have a list of all your customers and a second list of their recent orders. An outer join lets you see all the customers, even the ones who haven't ordered anything yet. It's for when you need everything from one table, no matter what's in the.
And last but not least, DevOps. Now this word can sound really intimidating, but for these exams, trust me, you do not need to be an expert. It's all about just understanding the main ideas. For instance, know what continuous integration or CI is. It's just the practice of everyone on the team merging their code together frequently to find bugs early. That high-level understanding is usually all you need.
So there you have it. We've looked at the blueprint for good design, we've gone into the engine room of the code, and we've walked through the lifecycle of development. And these aren't just random topics. They're all connected pieces of a much, much bigger puzzle.
And honestly, this is the most important thing to remember. Getting a handle on these fundamentals, it's about so much more than just passing a test. This knowledge is the bedrock of your entire career. It's what lets you build things that are strong, efficient, and maybe even beautiful. It's really what makes you a pro.
So we've laid out the fundamental pillars, the things you're definitely going to be tested on. You've got the blueprint now. The only real question left is, once you've truly mastered these concepts, what amazing things are you going to build? Thanks for joining me.